Hello, today we'll be looking and working through a paper. This paper is a GCSE Chemistry Foundation paper, which is for triple science students only. And this particular paper belongs to 14th of May 2020. I'm going to be working through the whole paper and show you how to best answer this question under exam conditions. Question 1 is looking at group 7 elements and has provided us with some data, and in the exam, if you have been given some data, it's possible they would like you to use it. So let's look at 1.1. What is the state of bromine at 100 degrees? So they are asking you, so bromine at 100, and the options are gas, liquid, or a solid. And if we was to look at bromine here, this one here, you will see that it has a melting point of -7 and a boiling of 59, which will then make that into a gas. So gas is your answer here. It then goes to say what temperature does chlorine gas condense at to form a liquid. Now if we look at chlorine, it already tells us the boiling point is -35 degrees, so all you have to do is just write down -35 degrees, and that will give you your mark. However, you possibly could also use your melting point as long as you write the answer as a -100 rather than -101. 1.3. Going down group 7, the melting point is something. This is because the size of the molecule increases, so the intermolecular forces are something. So if we was to go down the group, we will notice that the melting point will increase. Now, if the melting point is increasing, surely then the size of the molecules increase, so the intermolecular force also increases. Or alternatively, you could just say is the bonds, intermolecular forces are become stronger. Either answers should be acceptable in an exam scenario. Let's look at the next question. In this question, it says a teacher investigates the reaction between iron with chlorine, so that's the information that's been given to us. You then be given a label apparatus with your chlorine gas going in. It's been heated over iron wall in a gas tube, and any excess chlorine is been removed. 1.4. Why did the teacher do the investigation in a fume cupboard? The obvious answer is that chlorine gas is toxic. If it was flammable, it's colored, that will not make it any reasons why it should be done in a fume hood. 1.5. The word equation for the reaction is iron plus chlorine gives you iron chloride. Iron chloride. The teacher weighs a glass tube and content before and after. What happens to the mass of the glass tube and the content during the reaction? Give one reason why. Now here for 2 marks, you got 2 questions. What happens to the mass? And then give one reason. So quite often students tend to do the first question and then they miss out the easy second mark. So what will happen to the mass? The mass increases because chlorine atoms are now not part of the solid, and the reason being because there's a reaction that's taken place. So the mass of glass tube and content increases for 1 mark, and chlorine atoms are not part of the solid. You got iron chloride now, as it shows in the equation. Or you could write down mass of chlorine atom is now also measured. So you could do either answers for the second mark. The teacher repeated the investigation with bromine gas and iodine gas this time. 1.6. Fluorine is above chlorine in group 7. Predict what will happen to the observation of fluorine gas reacts with iron. Now, if you look at the observation for chlorine, iron burns vigorously with the orange glow. What you're going to predict is that if it's above, it's going to be more reactive, so it's going to burn very vigorously. For 1 mark. Or you could just say brighter glow. Now we already know that this one had an orange glow, so which we can predict that you're going to get an orange flame because it is more reactive. Finally, you can even say explode. So for 1 mark, you have got a range of answers that you can use. You only need one of these answers. This is all the possible answers that are acceptable. 1.7 balance equation between iron and bromine. Now do you notice this is bromine, INE, so it's Br2. Now on the left hand side you got 2 ions, and on the right hand side you got 2 ions, which is fine. On the left hand side, however, you got 2 bromine atoms. On the right you got 6, 3 2s are 6. So all you need to do is put 3 here, and then you have balance. Now you've got 2 ions on the left hand side, 2 on the right, 3 2s are 6, and then 3 2s are 6, and it is now balanced. Calculate the relative formula mass. So they have given you the masses here. So you have FeBr3. Now iron is 56, and you've got 1 of them, so you just do 56 times 1. Now we have 3 lots of Brs, which is 80, so you're just going to do 3 times 80, and the answer is 296. So quite straightforward. It's good to write them out, then at least you can see how many atoms you have of each one. Moving on to a different topics, model of atom. Atoms were first thought to be tiny spheres that could not be divided. Which particle was discovered to change this model of atom? So the answer is electron. Now you have been given an image which is got positive and negative in the middle of the atom. What is the name of this model? And the answer is plum pudding model, because it's got both positive and negative charges. 2.3. A scientist fired particles at gold atom. Some of these particles were scattered. The results led to a different model of an atom. Which type of particles were fired at the gold atom? And the answer is alpha particles. Which scientist first suggested that electrons orbit the nucleus at a specific distance? And the answer is Bohr. 2.5. The model of an atom used today has 3 subatomic particles: electron, neutron, proton. And this is the word they tend to use in the exam, which confuses students quite a lot. So you need to remember that subatomic particle just means proton, neutron, and electrons. Atoms of the same elements have the same atomic number because they have the same number of protons. Atoms of the same element can have different mass number because they have different number of neutrons. And finally, atoms have overall charge. Atoms have no overall charge because they have the same number of proton and electron, and the reason being, if you have 5 protons, you'll have 5 electrons, so it will be 5 positive cancelling out the 5 negatives. The radius of an atom is approximately 1 times 10 to the minus 14 meters. The radius of an atom is approximately 1 times 10 to the minus 10 meters. The teacher used a ball of radius of 1 centimeter to represent the nucleus. What could represent the atom on the same scale? And the answer is a sports arena, radius of 100 meters. Moving on to question 3. This question is about chemical reaction and energy changes. Hydrogen reacts with oxygen to produce water. This reaction releases energy. So there's a bit of information that we may want to use. Hydrogen plus oxygen makes water. Now remember, it says word equations, so don't start writing in symbols. They have now given you energy profile diagram where you are representing the different parts. So if you look at W, which is the energy, if you look at X, it's this part here, and this part here is called the activation energy. That's the minimum amount of energy you're going to need for the reaction to take place. Y here is the overall energy change. And finally, Z, this here, is the progress of reaction. Now remember, each of these are individually marked, so if you do get anything wrong, or if you can't remember any particular one, it's worth just having a guess because they have given you the answers. You just got to put them in the right places. The reaction between hydrogen and oxygen is used in a hydrogen fuel cell. What is the reason for using this reaction in the hydrogen fuel cell? And the answer is because it produces a potential difference, which is going to be used, which is going to allow you for the current to flow, cause a charge. A student investigated the voltage produced by a chemical cell. The student used different metals as an electrode in the cell. The metal used were copper, iron, and magnesium. Which two metals would produce the greatest? So this is what we're looking for, voltage when used in chemical cell, and the answer is going to be magnesium and copper. And for the second mark, it asks you to give a reason, and the reason is going to be the metals have largest difference in reactivity. So here again, you need to remember your reactivity series, which will come in handy. This question is about electrolysis. A student investigates the hypothesis that electrolysis of a salt solution produces a metal at a negative electrode and a gas at positive. So there is something for us to prove. you got a salt solution, graphite electrodes, and then electricity is flowing through. 4.1. What observation would be made at each electrode if the hypothesis is correct? Observation of the metal produce a negative electrode. Then if we look in a negative electrode, a solid will be produced. If gas produced at the positive electrode, and if it's a gas, then you are looking for bubbles in terms of observation, or you could write down fizzing or effervescence. Any of these answers are acceptable. In the table it tells you the results. If the salt is copper chloride, you got copper and chlorine, because remember, if you have a halide solution, you make the halide on the positive electrode. Potassium nitrate, you got oxygen and hydrogen because of the potassium being very reactive. And then in the final row you got silver nitrate, you're making silver Ag plus, which will go into the negative electrode, and then the oxygen from the solution, because it's a salt solution, and you make oxygen. Which salt solution in table 3 does not match students' hypotheses? And the answer will be potassium nitrate. So let's write down potassium nitrate. And the reason being, hydrogen is not a metal here. So hydrogen not a metal. Or you could just put down it's not. Again, it is like hydrogen is not a solid. So it's a gas being produced on both sides of the electrodes, and the negative electrodes, not potassium. And the reason being, potassium is more reactive than hydrogen is more reactive than hydrogen. So I've given you lots of different reasons, but you're only going to need one of these. Give the reason why graphite is used for electrodes, and the answer why we're going to use graphite this time is it conducts electricity. You can say it's an inert. You can say it's got delocalized. So let's write delocalized or free electrons. And also it's unreactive, it doesn't react. This question carries on about electrolysis, and here a student has done a investigation and they have given us a label apparatus where the paper has been soaked in electrolyte solution. It says it's got purple crystals, so it's got positive ions, purple colored negative ions as well. So the colorless ions are positive and the purple ions are negative. And the purple crystals dissolve in electrolyte solution. What happens to the purple colored ion? The ion do not move. The ion moves towards the negative electrode, or the ion moves towards positive electrodes. Now, because it tells you, it's talking about the purple crystal, and it tells you the purple crystals are negatively charged. So the answer will be they will move towards a positive electrode. And the reason being, it will attract the oppositely charged ion. So the electrode will attract opposite charged ion as the purple ions are negative. So this question is about aluminium. Aluminium is a metal, and what they ask you to do is to draw a line for each property. So what usually students do is they tend to draw a line for each option. So the figure, it says in bold, one line. So a lot of the times you will see that students would draw multiple lines and connect every single one and lose their marks. They've actually aluminium conducts electricity, and in order for something to conduct electricity, they need to have delocalized or free flowing electrons to carry the charge. And again, it's asked you, it's got high melting point, and you will be aware if something has to have a high melting point, that means it must have really strong bonds. And because aluminium is a metal, it means it will have strong metallic bonding between them, which means you need to apply lots of energy to break those strong bonds. They said that aluminium can be made from an alloy, and ask you the meaning of alloy. And the word alloy means it's a mixture of metals. Or you could just say it's a mixture of metals with other elements. Either answers should be acceptable. Now I think that aluminium is extracted from basic, and which is a mixture of aluminium oxide. It contains 15 and 25% of aluminium. Aluminium oxide also contains 53% of aluminium. How does this show that the basic is a mixture, not a compound? And the answer is that if you look at it, it tells you it contains here on this bit here that it's got a variable percentage of aluminium. It does not have a fixed percentage of aluminium, hence it's not a compound. So contains variable percentage of aluminium. Well, like I said, you can say it does not contain a fixed percentage of aluminium. Either answers again will be acceptable. 5.4, the waste material is stored in lakes of mud. The lakes of mud are held in place by dams. Figure 6 shows one of these lakes. So you got lake or work dam. So just two possible problems with storing the waste material in a lake. Now remember, in the bold is asked for you two different reasons. One mark for each reason. Here you can have a number of reasons. So you could just say dam can bust. It could be leak toxics. You can just say water pollution. I'm just giving you a range of answers, so you're only going to need any two of these. You can just say damage to habitat. It could be visual pollution. So these are all the answers that would be acceptable. It could be unpleasant smell. So as long as you just write any two of these out the list, then that should be okay. The question carries on with aluminium. Aluminium is extracted by electrolysis. Aluminium oxide is mixed with cryolite and melted. They're giving you the formula of cryolite, which is Na3Al6, and they're asking you for the total number of atoms in the formula. Now, number of atoms mean how many of each of the elements you have. So there's two different things here. There are three elements, which is sodium, aluminium, and fluorine. But in terms of atoms, you need to do is look at each one of these here. So you got 3 Na, 3 sodiums. Aluminium doesn't have any number, which means you got one of them, and F6 means you have 6 of fluorine. If you add them all up, the answer is 10. So you can write down 10 in numbers or in words to get the 1 mark. What is the reason for adding cryolite to aluminium oxide? Now, because aluminium is a metal, it has extremely high melting point, which means you will have to spend a lot of energy in terms of industrial breaking down and electrolysis, which will cost a lot of money. So what they do is if they add cryolite, the job of cryolite will be to lower the melting point of the mixture. Now, complete the sentence, choose the answer from the box. When the molten aluminium oxide and cryolite mixture is electrolyzed, the product at the positive electrode is oxygen, because aluminium is reactive, and you got aluminium oxide that you're separating with cryolite. And oxygen is saying positive. Oxygen has a 2- charge, so we'll go to the positive side. This product reacts with a positive electrode because the positive electrode is made out of carbon. So those are the answers from the boxes. Now a sample of it has Burex has 25% of aluminium. Calculate the maximum mass of aluminium that can be extracted. You have been told is 300,000 kilograms in this sample. You know it's 25%, so you could put 20% means over 100. And you know they're giving you the mass. So all you need to do is work out what is 25% of 300,000 kilograms. The answer is 75,000 kilogram, or so that's that. And it says it's got to be in standard format, because if you do not put in the standard format, you lose a mark automatically. If I put in standard format, it becomes 7.5 times 10 to the power of 4. Here we're moving on to the organic chemistry topic. They have used citric acid formula here, and it says complete the molecular formula. So it's easy to do this. All you need to do is count the number of each element. It already tells you got 6 carbons. If you start counting the number of hydrogens, you go 1, 2, 3, 4, 5, 6, 7, and 8. So that becomes H8. And now we need to count the number of oxygens. 1, 2, 3, 4, 5, 6, and 7. So for 1 mark, you just needed to write down C6H8O7 and what type of bonding is it. So you can see here that is a covalent bonding, the reason being all the elements are sharing electrons. And also is 2 nonmetals, which is carbon and oxygen, which is covalent bonding. This side it says the figure shows representative of molecule of citric acid A and B. Give 2 advantages of representing A compared to B. So what they're asking is, why is A a better model for citric acid as a display formula compared to B? So if we look at the two, you will see here you can see the single bonds and double bonds. So we can write down A shows all the single and double bonds, in the molecule. And if you also look at it, it also shows which atoms are connected to which elements. shows atoms or elements, or you can say which elements are connected to which other element, and so on. Thank you for listening to the working out of the paper. Don't forget to like and subscribe if you enjoy the content of the video, and if you would like me to do a working out of another paper.